Okay, this is the lecture video for MAC 1140 Pre-Calculus. We're in section 12.1, and in this section we're going to be taking a look at sequences, specifically how to generate the terms in a sequence, how to do a summation of all the terms in a sequence, and then also how to generate our own sequential functions. First thing you need to start with is the definition for a sequence. A sequence is a function whose domain is the set of positive integers. So when you start working with these sequences, there's going to be a rule, a function rule. Basically, the formula that you're going to be plugging into to generate all the terms in the sequence, and it will be made out of n's instead of x's. And also when you put your calculator in sequence mode, everything will convert over to n's. So what we're saying when we talk about the domain is basically you're being told what you're allowed to plug in for n, and you may only use positive integers. So although the set of integers includes zeros and negatives, while working with sequences, you will only be plugging in numbers such as 1, 2, 3, all the positive integers. Okay, what we have a picture of down below, diagram shows a sequential function. This is the rule that was used to generate the terms in the sequence. And as you look at each of these, you're going to see that when we do start plugging into these function rules, each one of these is a specific term in the sequence. Like this would be the first term where the n value was equal to 1, and then this answer was achieved by plugging in. So this would be the term listed in the sequence. Here is when n is equal to 2, and this is the answer that was generated by plugging a 2 into this function. So you would also see this term in the sequence. So just like you're evaluating any kind of a function where you're plugging in certain values and generating a y partner, but we're just calling these the terms of the sequence. Okay, there's a certain kind of notation that we use whenever we're talking about the first term, the second term, the third term, and those are little subscripts. So I'm showing you that below, that the first term would be notated like this, a sub 1. That just means we're getting ready to plug in n equal to 1. So that subscript indicates what you are plugging in for n. If we're talking about a sub 2, that means we're getting ready to plug in an n value of 2, which is also notated here. The function rule would be plugging in 1. Function rule would be plugging in 2, and so forth. That 3 would indicate that we're going to plug in 3, and so on. So if it said a sub 25, we'd be plugging in a 25. Okay, so we begin with trying to list the terms ourselves. This is the function rule that we're using. I want you to be able to generate the first 2 or 3 terms by yourself, by hand, and then I'm also going to demonstrate how to do it on a calculator. Okay, so if we were to generate these by hand, we're doing a sub 1. That means we're allowing n to be 1 in this function rule. So if n is equal to 1, we have a 1 on the top and a 1 plus 2 on the bottom. So the first term in the sequence would be 1/3, 1 over 3. When we go to the second term, that just means n is equal to 2. So we'd have 2 on the top, 2 plus 2 on the bottom. And that would leave us with 2 over 4, or 1/2. Okay, when we go to a sub 3, we're using an n value of 3. So that would be 3 on the top, 3 plus 2 on the bottom. Okay, so we've done 3 of the terms by ourselves. Let's go over to the calculator where I'm going to demonstrate how to get term 4 and term 5. And we can also use the list to check the 3 values that we got by hand. Okay, so the actual strokes that you need when you are putting this in the calculator, they are written on the next page. There are all of the things that I'm about to do right now, but I will just kind of summarize them as I do it for this particular function. I need to be looking at the function right now as I do it. So basically what you're going to do is, number one, you're going to make sure that the mode you're in is in sequence mode. You want to make sure that you're in sequence mode. So just hit the mode key on your calculator. There it is right there where the quit button is. I'll turn it on. I guess that would help. So, and then just make sure that you go over and press that and press enter. Then quit out of that screen after you've selected it. Then in order to generate the terms of a sequence, you're going to go second stat, second stat, over to ops, operations, and you're going to go down to sequential operations. This will be how you generate the terms of a sequence. So choose that selection, and it's like I said, it says all these steps on the next page. Then when it comes to, so we went second stat, I'll just kind of summarize. Second stat, and we went over to ops and down to sequence. It opened up a parenthesis, and now we're going to type in the kind of language that is used when you're trying to generate the terms of a sequence. Basically, what happens is you type in the rule, which will be this n over n plus 2. Then you mention the variable that's being used in this function rule, which is n. Then you're going to tell it where do the terms start, at 1, by allowing n to be equal to 1, and they end at n being equal to 5, and then you close the parenthesis. Okay, so let's do that now. Okay, so our function rule is n divided by n plus 2. Notice that the bottom has 2 terms in it. You're going to want to wrap that in parentheses, telling your calculator to calculate this value first, then do the division. So this will be, now if you want to get an n, you just go right here to where you get all the variables, but since you're in sequence mode, instead of typing an x, it's going to give you an n. So you're going to go n divided by n plus 2, close that up. So you just fed in the function rule. Now separate it by a comma, tell it the variable that is being used in this function, that's n, another comma, and then tell it that the terms start by letting n be equal to 1 and going all the way to 5. Now close that parenthesis, and it'll generate the terms in the sequence. Now your calculator will give them to you in decimals, but you're going to want to give them in fractions so that you're not rounding off answers, but rather giving exact answers. So you know how to get from decimal form to fraction form. That's always the same way. Hit the math key and then enter twice. Okay, notice that we're seeing the first 3 answers that we got, 1/3, 1/2, and 3/5. And then if you side arrow over, you'll see the other 2. Okay, so here's the last 2, 2/3 and 5/7. Okay, so that's how to generate terms using your calculator, and also how to check the ones that you've done. Okay, moving on to example 2. In example 2, we just have, let's see, we have a -1 out here as a coefficient. By the way, when you have -1 raised to a power involving n, that's the way of making the terms that come out in the sequence alternate in sign. In other words, this is a way of getting one term to be negative, the next one positive, next one negative, next one. So alternating signs are achieved through this. And the power is either n plus 1 or n minus 1, depending on what sign you want that very first term to be. So this says negative 1 raised up to a power of n plus 1 times n squared. So again, I'm going to do the first three terms by hand, and then we'll go to the calculator to get a little practice doing that again, as we did example 1. Okay, so again, this means this 1 means n is equal to 1. So if you were doing this by hand, it would be negative 1 raised to a power of n plus 1. Well, my n value is 1. So that would be 1 plus 1. So negative 1 raised to a power of 2, and then we're multiplying by the n value squared. Okay, notice that this power right up here is even. 1 plus 1 is 2, and anytime you're raising negative 1 to any even power, it's going to come out positive 1. And then 1 squared is also 1. So that means that your final answer for term 1 is 1. Okay, when you go to term 2, follow this rule. It's negative 1. We are using an n value of 2 as suggested by that subscript. So it would be n value of 2 plus 1. Notice that this is an odd number, and anytime negative 1 is being raised to an odd number, you're going to get negative 1 for that coefficient. Don't forget, we're also multiplying by the n value that we are presently using squared. So this would be negative 1 times 4, or just negative 4 for our second term in the sequence. Third term, following yet again that rule, negative 1 coefficient raised to a power of, we are now using the n value 3, suggested by that subscript. So the power is 3 plus 1. We've got an even power. Negative 1 to any even power is just 1. And we're multiplying by n squared. Our n value is 3. We're squaring it, so that's a 9. Okay, enough by hand. Let's try and see if we can get these using the calculator. So I was demonstrating that it has to be in sequence mode. Well, it already is because we just did a problem. And then once we want to fill in all the parameters of the sequence, we go to Second, Stat, over to Operations, and down to Sequential Operations. It'll open it up, and now we're going to fill in the parameters of the sequence, starting with the sequential function itself, which was negative 1 raised up to a power. Now that power has 2 terms in it, which means that needs to be done before the negative 1 gets raised to the power. So you want to put that power in parentheses, which is n plus 1. N plus 1. So close that parentheses so your calculator knows you're done feeding in the exponent, and you're now on to the next term, which is times n squared. So times, call up the n again, put a square on it, and then don't forget to feed in the rest of the parameters. All we've done is put in the function rule. Negative 1 raised to a power of n plus 1 times n squared. As soon as you get done typing in the function rule, then you're going to tell it that the variable being used in this function rule is n. Then you're going to feed in from what term to what term. We're starting with term 1. And we're going all the way to term 5. And then close the parenthesis. And there you go. Here are the 3 terms that we got. 1, negative 4, and 9. Last 2 terms, negative 16 and 25. Okay, so we have all 5 terms. Some by hand, and then we did some by calculator. Okay, determining a sequence from a pattern. So in this particular problem, what you're trying to do is to come up with the function rule that we've been plugging into. You're trying to come up with it yourself by trying to observe how are the terms in the sequence, how do they seem to be formed? Mathematically, how are they formed? So, and remember, you're always starting by plugging in 1, then plugging in 2, and you need to be thinking about what can be done to those numbers that you're going to be plugging in. Like here, somehow they achieved this by plugging in 1, but we're going to try and figure out what formula could we plug in 1 to in order to come up with this, then to come up with this, then to come up with this. So I'm noticing that whatever term you happen to be on, that's what is in the numerator. So how about if we just let our function rule be n on the top, just whatever the n value is, and then I'm noticing that all of these denominators, this is 13 more than that, this is 13, this is 13 more, all the denominators are 13 more than whatever the top is. So these are just mere, it's just by observation that you're getting the answer. You're just trying to observe the pattern that is suggested by the numbers that are in the sequence. So the rule that's being used there is n divided by n plus 13. If you were feeding that in a calculator, you'd have to put parentheses around that. But you're not being asked to do that here. You're just coming up with the rule. Okay, this one. This next one, we have, let's see, we have a 1. And remember, you have to be able to plug in a 1 into some formula to get that. You'd have to be able to plug in a 2 to get this. You'd have to be able to plug in a 3 to get that. So let's see, what could we possibly use that would get us a 1 for our very first term, but yet it would generate fractions that are based off of 3. Because this is 3 to the power 1, 3 squared, 3 to the third. So if we used something like, and you can mess around with this, you could say, okay, would this work? Okay, remember, you need to be able to plug in 1 to get the first term, 2 to get the second term. Would this work? If I put a 1 right in here, I would get 1/3. That's not going to work. I need to get just a 1. So if I was to, let's see, plug in a 1 right there, I know that 3 to a power of 0 would get me a 1 right here. So how about if I do plug in a 1, but I subtract 1? Because then I would have a 0 there. Let's see if this would work. I'm trying to figure out how to get that very first term by plugging in 1. Let's see. If I was to do this, I would go 1. Let's see if this will produce the first term. Put in my n value, but subtract 1. That would give me 1 over 3 to the 0, and anything to the 0 power is 1. So I would actually get a 1 in the very first position, just like we see right here, by using this formula. Does it work on the other terms? You have to check it out more than just for, you have to check it out for more than just the first term. So let's see. How about if I was to use this formula, but take it into the second term, where n is equal to 2. So I most definitely got the first term that I needed to get, where I was using an n value of 1. Now I'm going to try and get the second term, where n is equal to 2. So that would be 1 following this formula. I'm using an n value of 2 but subtracting 1. That would give me 1 over 3 to the 1, or 1/3. So I have achieved the proper second term. Likewise, if I was to use n equal to 3, you see how it continues to work here. I'd be using that formula again, 1 over 3 to whatever the n power is. I am now on 3, but subtracting 1, that'll get me 1 over 3 squared. And yes, if it's working for these 3 terms, you know that it's working. Okay, so the formula for this one would be 1 over 3 to a power of n minus 1. Okay, moving on to part C. And in part C, we see these alternating signs, positive, negative, positive, negative. That's achieved by having a negative coefficient raised to some power that involves an n. The typical ways to get that are n plus 1 or n minus 1, depending on whether you want, and you choosing n minus 1 versus n plus 1 depends on what you want the first term to come out like. Do you want it to come out positive? Do you want it to come out negative? I want mine to come out positive 1. Then I'm also trying to get fractions, so I have to think about how that's going to happen. So first of all, let's see. We can try negative 1. And let's see, we're going to be trying to get a positive to begin with. So I'm going to try n minus 1. We can always change it to n plus 1. And to get these fractions, I could do 1 over n, because if I do 1 over 1, that would get me the first one. Then when I get to, remember, these have to come about by you plugging in a 1, then you plugging in a 2, then you plugging in a 3. Could I plug in these numbers into this and get the fractions that I'm seeing there? Let's see, if I plugged in a 1, I would get a 1 there. If I plugged in a 2 for the next term, I would have 1 over 2, that is the next fraction. If I plugged in a 3 for my n value for the third term, I would get, so that's working, the fractions are working. Do I get a positive for my first term? Let's see if this works, because we can always change this. Typically when you're alternating, that power will either be negative n minus 1 or n plus 1. But I'm trying to get a positive first term, so let's see. For n equal to 1, does this work? Do I actually get a positive 1? It would be negative 1. My n value would be 1, take away 1, and then this fractional part would be 1 over 1. So I would have negative 1 to a power of 0, which is positive 1, times 1. Yes, I do get the proper term. Let's try it again. This time let's go for n equal to 2. Make sure it works. So I'd have negative 1 according to this formula that I'm testing out. And it's going to be the n value minus 1. Well, I'm on an n value of 2. Subtract 1. And then it's 1 over the n value. This time I'd have negative 1 raised to a power of 1, which is negative 1, times 1/2, and I get exactly what I want, that negative 1/2 value. And then I'll just try it one more time just to show you what's happening. N equal to 3. That means I'd be using again this function raised to a power of n minus 1. And then to get the fractional part, it would be 1 over n. Okay, this would end up being negative 1 raised to a power of 2. Negative 1 times negative 1 is 1. 1 times 1/3, and I'm back to a positive value. So to get signs to alternate, it will be a negative 1 raised to either a power of n minus 1 or n plus 1. Okay, so let's see. Just filling in the rule that I have tested out, which is this. So negative 1 raised to a power of n minus 1 times 1 over n. And you can use a parenthesis there. You can just feed it into My Math Lab like that. Okay, that takes me to next page. And in the next page, I wanted to remind you of the factorial symbol. You may have seen this in your previous classes, but the factorial symbol is just a way of indicating a product. Like for instance, you see the definitions there, and there's several examples there if you don't understand this definition. But if whatever the number is next to the factorial, that means you start with that number and count down from there in increments of 1 as the factors that belong to this product. So you would start with a 2, next number would be 1 less than this number, and you stop once you get to 1. So if you're at 3 factorial, you start with a 3, count down. Next number is 1 less. Next number is 1 less than the one in front of it, and you're forming a product. Stop when you get to 1. If you see 4 factorial, it starts with 4, go down 1, go down 1, go down 1, stop when you get to 1, and multiply all those factors, and so on. Now, if the factorial is too big, you're not going to want to sit there and multiply the whole thing out. So be very good if you know where to go get the factorial symbol. That way you can have your calculator do 16 times 15 times 14 times 13 times 12 all the way down to 1. It'll do this for you also, and then it'll do the division. So that is under the math key, where to get this factorial. So I'm going to demonstrate. These are the buttons that I'm going to be hitting, or the calculator strokes, and I'm just going to demonstrate it. Okay, so I'm going to do 16, go to the math, arrow over to probability. That's where you find the factorial key. And we're going to hit that factorial symbol, then divided by 14. Again, go grab the factorial symbol, math, arrow over to probability, and down to option 4. Okay, and then press that. Answer is 240. So very easy, not much to do. You're going to let the calculator handle these problems. Okay. Okay, recursive formulas. Recursive formulas just mean that they are starting you off with the first value, and then they're going to start you off with the first term in the sequence, the first value. And every term after that is some manipulation of previous terms. Once they give you that first term in the sequence, every term after that will be calculated using previous terms in a sequence. So this first one is just to see if you understand the definition of recursive, and that if you could follow an example. But see how they're saying you're finding term a sub n, but you're using a term to get it that is a previous term. The term called n minus 1 would be the term that comes before this. So you are using a previous term to get a successive term. So this is an example of a recursive sequence. Okay, then let's actually work with some recursive sequences. Like, for instance, here is another example of one. They're starting you off with the actual first term, and sometimes they can start you off with, more than one of the terms. And they're telling you how to get each successive term after that, how to get a sub 2. They've already given you a sub 1. You already have this one. This is the like I said, recursive sequences. They're starting you off with one or more terms, and then you're going to find all the subsequent terms. So if I'm going to get a sub 2, that means I'm going to follow this formula right here. So this would be 7 minus, now let's work on reading this together. What this means compared to a term that you're finding right now, this means use the term that was 1 before this. So the term that was immediately previous to this. If this said n minus 2, then you'd be using n of the value that you got 2 terms ago. This means use the value that you got 1 term before this. So that would be the 4. Answer would be 3. So I just found a sub 2. Now I'm going to find a sub 3 following that same formula. 7 minus the term right before this, 1 term before this, which was a 3. Brings me right back to 4. So I got 4, then 3, then 4. And you're going to just see that this is an alternating sequence of numbers that just goes from 4 to 3 to 4 to 3. If you were to start this using the formula again, this time it's going to be 7 minus the term that is 1 term before it. That's what the minus sign means. 1 term before that. The value was 4. And so I'm getting a 3. Okay, and let's just go ahead and put this in. These are a little harder to put in the calculator, but I'm going to demonstrate what these calculator strokes say to you right here. And you can only press in, pretty much the basic ones, because if they offer you any more than one starter term, then it's just best to do it by hand, which I'll demonstrate in the next problem. But these are the steps that you're using. You're going to open up to a screen that's going to ask for a minimum value. It's going to ask where it finishes. Let's see what else. No, it's going to ask you for a minimum value and where the first term and what that term is. And then you're going to have to give the actual recursive formula in terms of U, because that is what this calculator, TI-83, for all the TIs, demand it be given in U form. So that's the syntax for this. I'm just going to demonstrate it. Okay, so let's see, second quick. All right, so let's go to mode is sequence. We're already in sequence mode because we've been using that. But this time, you're going to press the Y is equal to key. Let me clear out what's here. Clear out there. Clear out what's there. Okay. And even this wouldn't be here. All of these, it would just look like that when you first get into this screen. Okay, so what you're going to do at that point is you're going to feed in the n minimum value. So the n minimum value is this one right here. Okay, and you're going to y is equal to do this. So that minimum value is 4. Tell your calculator what is in that position. What is the actual minimum value that's in the first position? And that gets filled in right here. So let's see if I can write that. This gets filled in under the third position down. Okay, then you're actually going to fill in the rule, but in terms of U. Fill in the function. And you're going to get U-type variables under second 7. That's where you find the U variable. Okay, so I want to fill this in, but written in terms of U. That's how the recursive functions need to be filled in terms of U. So I'm going to go 7 minus, and instead of a sub n, I want to get U minus 1. Okay, so I'm going to go second 7, there's my U, minus 1. Okay, so I'll press that in. Let me make sure that I am plugging that in properly. Okay, yeah, I don't think I typed, okay, no, I didn't type that in right. Let me clear that out. Okay, so to type that in, we're going to type it in like this. We're going to type in 7 minus, and then we're going to call up the U variable first. So second 7, get that U, and then tell it what the subscript is. So where you see the a recursive term, that's where you're going to fill in the U and then tell it what term it is. So that is where you put in the n minus 1. Okay, and then when you want to go get those values after you've typed it in, So again, you're just going to type what you're seeing right here, 7 minus, but instead of this A, you're going to type in a U, which you grab right here, second 7, to get that U variable, and then tell it what the expression is, the subscript that's in the formula. And then I typed in n minus 1. Okay, so now to get the values, go to second table. Okay, now we were looking for the very first value, which was at n equal to 1. And it's got an error for the first two because these sequences are not defined for anything other than positive integers. So they actually start at 1, so it'll give you an error for anything else. So when we were doing the first term, we did get a 4 because they gave it to us. It's not that we got it, they gave it to us. That was our starter value. When we went to go get the second term, we got a 3. Notice that you still see those on your paper. So this was given. This was the first one that we generated. Then when we got to the next one, when we went to the third term, we got a 4. And you can see those partners as you got along. This was given. This was the first one that we got, where we got a 3. Then the next time we went to calculate one by hand, we got a 4, and so on. And it's giving you the fourth term and the fifth term. See, this is n is equal to 4. This is n is equal to 5. So we have an answer of 3 and an answer of 4. Now we went all the way to this, an answer of 3 and an answer of 4. Okay, so those are the first 5 terms, a little bit tricky to put into the calculator. I would just do the recursive ones by hand because it's kind of a pain to go and grab that U variable. And if they give you too many starter terms, then it becomes a real mess. So let's do, if they do give us more than one starter term, we're going to do it by hand. But a single one, that you can press it in like that. Okay, so calculate these terms by hand since there are 2 minimum recursive values, just reminding you of that. And let's read this together. What this is saying is that when you want to get any terms other than the ones that have been given to you, because they gave you the first one, they say this is 4. They give you the second one, they say this is -1, and then you start generating your own. So you want to be able to read this. This says multiply 2 terms. The term that was 1 before the term that you're on now, as well as the term that was 2 terms back. So when you're going to get this term right here, use the term that was 1 before this, the value that was there, and also use the value that was 2 terms ago, which was this -4. Likewise for this one. This says use the value that was 1 term ago, which is this one right here, and also use the value that was 2 terms ago, which was -1. Okay, so you end up with -4 as your answer. So given, we generated. Now let's get that 5th term. You just have to know how to read that recursive formula. Okay, again, we're doing a product. We're using the value that was 1 term before this and the term that was 2 terms before this. And so our last answer is -16. Okay, just a little experience with the recursive formulas. Last, we come to summation. And the summation means that you're taking the terms in a sequence and summing them all together. We can also get our calculator to help with this. So in the first example, example number 8, having to do with summation, they're not asking you to actually do the summation. They just want you to make sure that you can read the formula, which is out in front of the summation symbol. This is called the summation symbol. That would mean take all the terms generated by this formula. How many terms do you generate? You're going from 1 all the way to n. So since they didn't tell you where to stop here, that's why they're not asking you to sum it together. You'd have to know where to stop if you were going to generate a specific number of terms and then add them all together. But again, we can get our calculator to do that, to generate all the terms just show that you understand how to read the formula and how to generate a few of the terms. So like for instance, if we were complying with this problem right here, where we were generating the first term, second term, and the nth term, it would just be following this. For the very first term, where the k value is equal to 1, you would just be putting a 1 in here and squaring it, so it would be 1 over 9. Okay, then if you were going to do k equal to 2, then it would be 2 squared over 9. And I guess I could write that over here. It would be 1 squared over 9. When k is 2, it would be 2 squared over 9, just following that formula. And if following that pattern, it's just whatever the k value is. So if you're going all the way to where you're letting that k value spiral from 1 to n, this is the ending term here. This is the beginning term, and then they move sequentially until you get up to that ending term. So now we're talking about k has gone all the way to the last term. Following what I did here with my specific k values, I would square whatever the k value was, just happens to be n this time. And then the denominator is 9. Okay, now in the rest of these problems, they're actually going to tell us where to stop rather than just giving us a general, hey, stop at n. So like for instance, in this problem right here, we're doing 6 terms and we're actually getting each one of them using that formula. And we're starting with 1. So the first term would be 7 times 1 minus 7. So 7 minus 7 would be 0. Just to show you some of these terms. And then if I was going to do the next term, it would be, now go to the next highest term, 7 times 2 minus 7. So this would be 14 minus 7. Then if I was going to go to the next term, it would be 7 times, go up to the next highest one. I already used k equal to 1, k equal to 2. And I'll put that these are the k values. Now I'm using k equal to 3. So your nice calculator is doing all of this for you. So that would be 21 minus 7. They're just, you know, multiples of 7, and then you're subtracting 7. And you would just keep going until you had 6 terms there all generated from this. So maybe you can still show your work. Just show that you know how to use this formula and that you understood where to start with this formula at 1, and then your work is showing that you knew to go to the next highest number, but you're letting your calculator take over at this point. Your calculator is going to generate all 6 terms, plus it's going to add them all together. So I just want to demonstrate the strokes for that. They're written out for you right here. We're still going to go in under the second stat key, but this time we're going to keep this in function form. You could actually keep it in n form if you wanted to. That would be fine if you did. And we're going to go to the math key, because now you're doing a type of mathematics where you're adding all the numbers in the sequence. But just so I'm following the instructions that I typed for you, I'm going to quit out of here. I'm going to go to mode. Like I said, you could keep it in sequence mode if you want. I can quit. Okay, so now when we go to put this in, we're just going to go second stat. We're going to be doing a certain type of mathematics, which is called the summation, which is option 5. Okay, then it's going to want to know what sequence are you doing this on. So if you're going to feed in a sequence, let's remember how we fed in a sequence. We would go second stat, we would go to ops, and we would press in sequence. And then we would tell the calculator what the parameters of the sequence was. We would say, what is the rule that's being used in this particular formula? Well, 7x minus 7, or if you left it in sequence mode, 7n minus 7. Okay, then we would put a comma, and after doing that we would give the variable that's being mentioned. Just hit the variable key again. That's the variable being used in this rule. Then we would put another comma and we would put the starting value, which is 1, and then comma the ending value. Okay, and then we would close that sequence. So that's the parenthesis that goes with this one, and give it one more. And that means that if we had generated all 6 terms by ourselves and then added them all together, we would have gotten 105. So that's how to put it in your calculator. Okay, so we're just going to keep practicing that. There's quite a few summation problems in the homework. So let's try this again. Now some of them, it doesn't make sense to put it in your calculator. So when it doesn't make sense to put it in your calculator and go through all those keystrokes, then we won't. Like for instance, this one. It says that, notice how there's no x. That just means the terms are going to be 9 over and over again. You're going to start with term 1, which is 9. And remember, we're doing a summation. So not only are we listing all the terms in the sequence, but we're putting plus signs between them because we want to add them up. And then the second term, it doesn't change. This is called a constant sequence, where all the terms continue to be the same because there's no variable. And so you see what's going to happen here. They want us to do that 9 15 times. So what does this end up being? 9 times 15. The 9 is occurring 15 times, and that answer would be 135. Doesn't really make sense if you realize that's what's happening. Now I'm spelling it out for you in as detailed a manner as I possibly can, so you'll realize that it's just 9 times 15, but you might realize it much more quickly than the time it took me to do this, so it could actually be a pretty quick problem. Okay, this one, the numbers are actually changing because it's a variable. Not only that, there's a lot of numbers here. So this totally makes sense to put it in the calculator because you're not going to sit there and list all the 49 numbers and the 49 terms and then sit there and add them together. Okay, so you want to be able to get your calculator to help you do this. Okay, so let's try and use those keystrokes again. Okay, first let's tell our calculator that we're doing a summation. So we're going to go second stat, tell it that we're doing a summation by going over to mathematics and choosing the kind of math operation we're going to be doing on the sequences, which is a sum. So we're going to go like that. Then tell it what you want to do a sum to, the summation of, a sequence. So to call up a sequence and to actually feed in the parameters of the sequence, again you go second stat, over to ops, down to sequence. Then press in the parameters of the sequence. So give the function rule, x or k doesn't matter, x, k, n doesn't matter. Then tell it what the variable was used in that really simple rule. You have to say it again. Then tell it where it's starting. It's starting at 1 and then going all the way to the 49th term. So now press in 49, close that, second parenthesis to go with the beginning one, and enter. And so the answer for this, if you had listed all of these terms and added them together, they would sum together to be 1,225. Okay, moving to number 12. Get a little bit more practice with that. This time we're going to be doing the summation of k cubed, starting with a k value of 6 and running those values all the way to 15. So we're going to go second stat, tell it that we're doing a summation by pressing sum, tell it that we're doing a summation of a sequence of numbers. So second stat again, over to ops, and we're going to pick sequence and then put in the parameters of the sequence. first starting with the rule that is being used, the formula that's being used. So x cubed, then tell it the variable that was used in the actual formula, which was x, and where it's starting. This time it's starting at 6 being plugged in and running all the way to a value of 15 being plugged in. Close, close. And the answer for that is 14,175. Okay, number 13. So number 13, this says express the sum using summation notation. So now we're moving to a couple of problems where we're trying to, again, look at the patterns in the summation. We already went through about 3 of these problems where we were just trying to observe the patterns and look at the kind of numbers that are being generated in the sequence back in the previous problems we did. Now it's, you still have a sequence of numbers, only there's plus signs between them. So we're just trying to figure out how can we get this using an n value of 1, an n value of 2, n value of 3, and so forth. You can assume that they're starting at 1 unless it's, something else is indicated there. So let's see. How about if we used a formula where the top is the n value, because you can see that it matches the n value, and then the bottom, let's see, how could we get this bottom if we're using an n value of 1? We could go this n value plus 4. Would that work here? This n value plus 4. Yep. This n. Okay, so we have a formula. That formula is k, just because they're mentioning k over here. The bottom is achieved by going k plus 4. And these are really the n value. They're referred to as the k values. I keep calling them n because I'm used to talking about the sequences. So we're starting with 1 and going out to the 11th term. So this is what you'd be feeding in My Math Lab. You're going from the first term to the 11th term. So you're going from a k value of 1 to a k value of 11. This is the formula that would generate these kind of fractions. So just by observing the patterns and what that first and last term is and the form of these terms in the middle. Okay, going to number 14. Complete the formula given below. The terms here would be 1, 2, then 3, all the way out to the nth term. And so let's see, we want to know, choose the correct formula here. We're going from 1 to n. Okay, let's see, what are they asking for? Choose the correct formula. Okay, there's something missing here. This is supposed to be equal to 15. So cut that off. So choosing the correct formula, that would produce 15 as the last value. Okay, so if we wanted to choose 15 as the last value, and we're going, yeah, some of this got cut off. We're going out 1, 2, 3, 4, 5 terms. And ending up with 15. So what kind of formula could possibly be used in this case? Let's see, let's check out our options here. If we were going out to the 5th term from n equal to 1 to n equal to 5. Because I believe this problem, I'll have to fix this outline, talked about the first 5 terms and getting a 15. By knowing that we were only using the first 5 terms, that's how you know you're going to get a 15. Because if you had 1 plus 2, they talked about the first 5 terms, but as I said, that got cut off. There'd be a 4 in there. You're going to 5, so when you add all of these up, 3 and 3 is 6, and 4 is 10, and 5 more is 15. So you can just add that to your outlines, and I'll fix the print on the outlines. So this was all about the first 5 terms. Those are them. We know it has to add up to 15. What kind of formula would give us a 15 at the end? Well, we could take, let's see, if we're going out to the 5th term, we could go 5 times 6. Now we need to get a 15, but divided by 2. That would give us 30 divided by 2, which is 15. We could call this the nth term, and we could call this the n minus 1 term. So the formula could be like this. We're going out 5 terms, which was described in the problem. And if we multiply that by the previous, or actually n plus 1, that would be the subsequent term. The nth term would be the 5th term. The n plus first term would be 6. So 5 times 6 divided by 2. Excuse me. So that would be that answer. I think that might be the last problem. Yes, and that completes section 12.1.